So in these first two problems, we are asked to find the roots. Now, what's another word for a root? Zeros, solutions. How can I find the solutions to this polynomial here? What should I do? How would I find the solutions? What do I need to do first? Right. First, you need to factor this, right? Because the factors will tell you the roots or the solutions. So let's go ahead and start factoring this. Now, Grace, what did we say to do first?
Take out the x.
Take out your GCF, which is? This one's actually quite easy. So we're left with x squared plus 5x plus 6. I took my x out. Now what? Now we factor it, right? We do the x method here. What goes up top?
A and C.
Right, which is? A times C is 6, and in the bottom goes B, which is 5. And then we ask ourselves what?
What times what?
What times what is 6, and what times what adds to be 5? And what two numbers do we come up with? 2 and 3. So are these my factors? Why, yes, they are. Because why? There's no coefficient on my x squared. So these are my factors. So I have x, then I have x plus 2, and then I have x plus 3. Now what do I do? Yes, so these are my factors. To get my solutions from my factors, you set each one individually equal to 0. So my first factor is already solved. It's done. X equals 0 is my first solution. Then what do I do to x plus 2 equals 0? And x equals negative 2 is my second solution. And then? Beautiful. So these are my 3 roots, my 3 solutions, my 3 x-intercepts. Any questions? Okay, you guys try part B. Okay, guys, so hopefully you finished part B by now. Shh. What should you have done first here? Pull out your GCF. Beautiful, which is what? X. So we're left with x cubed minus 2x squared plus 4x minus 8. And then, what did you do? Yes. What method of factoring do we apply here? Factor by grouping. Good. So you group the first two, group the second two, pull a GCF out. So what are we going to pull? X squared. And what are we left with inside? Wonderful. X minus 2. And then what do we pull out here? So hopefully by this point, we're all super confident. We've done this a million times now. Factoring by grouping, we should know what to do here. So now, what's my first factor? Right, the GCFs you pulled out, x squared plus 4, and then our second factor is? Good. I should hope that everyone got to this step. Now is where it gets a little bit new for us. What do we do now? Set them all equal to 0. So x equals 0, that's our first root. Then x squared plus 4 equals 0, and x minus 2 equals 0. This is already solved for us. We're done. That's our solution. What do I do for this second root? Minus 4 over, so I have x squared equals negative 4. Now what? Square root both sides. What happens on that left-hand side? Right, the square root and the square cancel, and I'm just left with x. What happens on the right side? Yes, so the square root of 4 is 2. What is the square root of a negative? So I have 2i. What am I forgetting? Whenever I square root, it's also what? Plus or minus. Good. So it's plus or minus 2i. Jeepers. So my two roots are 2i and negative 2i.
Wait, your x squared plus 4 isn't that? Oh. I was gonna say, like, sum of cubes, but there's no sum of squares.
Right, there is none. Yep. So I have 4 roots. Looking at these two problems, how many roots did I have for A? 3. How many roots did I have for B? What could have told us how many roots I should end up with?
The number of numbers. Yeah.
Right, the leading term. This is x cubed. So because there are 3 x's in our leading term, I should end up with 3 roots. This is x to the 4th. Because there are 4 x's as my leading term, I should end up with 4 roots. Okay? So this is a key indicator of how many roots you should end up with. All right. On to the next type of problem. If you have n equals negative 3 as a root of the equation f of n is equal to n cubed plus 8n squared plus 24n plus 27, find all the other roots. How do I do this? This was the homework problem. No, it was not. Never mind. So if I'm given a root, how do I then find the other roots of an equation? Algebra. Yep, we apply algebra.
You solve the equation.
What did I say is the reason why we divide polynomials? Why do we divide polynomials? To take it out of the equation so that we can then find the other roots. So if I'm given a root and an equation, divide that root out of our polynomial to then factor that polynomial to find the other roots. So I'll show you what I mean. Which method of division do you think I should use here? Yes, synthetic. So what am I dividing by? Negative 3. And what goes on the inside? 1, 8, 24, 27. What do I do? Bring the 1 down. Then, negative 3 times 1 is? What is 8 minus 3? Negative 3 times 5 is? Beautiful. Now what do I do? And you get? Positive 9. 9. Good. So what's our remainder? 0. Nothing. You don't have a remainder. So after dividing the root of negative 3 out, what do I end up with? X squared. So now, how is this my root? What I just wrote down? What is that? Right, that's the quadratic after you divide the factor of negative 3 out of our polynomial, out of our cubic, right? So now what do I need to do to this to get the other factor it? Okay. How do I factor this? Okay, so I'm going to tell you, I'm looking this right now. X factor, what multiplies to be 9 but adds to get 5? So let's think of the factors of 9. The factors of 9 are 1 and 9. Are those two numbers ever going to add to get 5? What about 3 and 3? So what do I actually need to do here? Oh, you have to apply the quadratic formula. Yes, you do. What is our quadratic formula? Plus or minus the square root of all over? Beautiful. Probably. Okay, so now we just plug in these numbers. -5 plus or minus 5 squared minus 4 times a, which is 1, times c, which is 9, all over 2 times a, which is 1. What do I do first here? Right. You are solving underneath your radical there, your square root. You're solving for the discriminant, actually it's called. So 5 squared is 25 minus 4 times 1 times 9 is 36. So what is 25 minus 36? -11. So do you think that I am trying to plug this into my calculator to get a decimal? No, right? I'm just trying to simplify this as much as I can to get my root. So how can this be simplified more? There's one more thing you can do. You can pull an I out. And whenever you have a negative square root, pull the I out to replace the negative. So this becomes -5 plus or minus I square root of 11, radical 11. So I have two more roots here, and I know they're super ugly, but that's okay. They're still our roots. X equals -5 plus I square root of 11 over 2, and x equals -5 minus I square root of 11 over 2. And yes, sometimes you are going to have to simplify that square root. Simplify that radical. Who remembers how to do that?
The tree.
The tree. Good. You do the factor tree. Beautiful. Any questions at all on this problem? Okay, you guys do number 3. So on the back, even though it doesn't look like it, 4 and 5 are the exact same type of problem in a different format. So it says the table below contains values for the function f of x equals x to the 4th plus 3x to the 3rd minus x squared minus 3x. Using the table, determine the linear factors of the function. So, with this table, what are we given? We're given a what? A 0. Well, what's another word for 0? X-intercept. Yes. This right here tells us that we have a solution at x equals -1. So, what you're going to do here is you're going to devote this root. Using division, you're going to take this root of -1 out of our polynomial. And you're doing the exact same process as on the front. Once you divide it out, you then factor whatever polynomial you have left to find your roots. So you guys go ahead and do 4 and 5.